Okay, over to this demonstration here. So, volunteer that I picked on from the audience, come back if you would. I want you to feel this. And maybe let the camera see you also. So, how heavy is that? I mean, we just, light, medium, heavy?
Medium.
Medium, okay. Personally, I think it's kind of heavy, but maybe he's been working out, so. This block and tackle is an example of what's called a simple machine. So I remember, I think it was 6th grade, we studied simple machines. How many of you have heard that phrase before? Okay, probably more of you than are actually raising your hand. A simple machine is designed to give you some sort of mechanical advantage. A mechanical advantage means that you can actually lift this up without having to apply the full force, behind, without counteracting gravity entirely. So, this is really tangled now. Let me fix that. Okay, so go over here and feel, so pull on this and feel, how does that compare to the weight of this thing?
It's a lot lighter.
Okay, a lot lighter. Can you estimate, is it 10, 20, 30, 40%? Something like in there? More?
Percent of the original weight?
Yeah, percent of the original weight.
Like 10.
Okay, so maybe 10% of the original weight. Okay, it is between 10 and 20. That's pretty much it. You can sit down now. So you can lift this up even though you're not applying the full force. There is a price to be paid though in these simple machines. So if you look carefully, if I raise this a foot, see how much rope I need to actually use to do that. So is that about a foot? So look at all this extra rope I've got here now. So I'm applying a smaller force, but I have to do so by applying that force over a longer distance. And as we'll talk about later in the semester, it turns out the product of the force times the distance has to be equal to the product of the weight times the distance I'm lifting it. So it's kind of a zero-sum game as far as the product goes, but this allows you to lift things much heavier than you would normally be able to lift.